Bear with me. I've just had a terrible glitch, as it always never seems to work when you want it to work.
No problem, Gideon. Take your time.
Sorry, I pressed the wrong button, Gilles.
No problem.
I just got to get the presentation back up. It's on its way. Yep, there we go.
I'll let you know when I can see it.
Yep, no worries, Gilles. Bear with me. Right, there we go. Can you see that now, Gilles?
Yeah, I can see that, yeah.
Right, okay, brilliant. Right, thank you all once again. Apologies for that. Yes, I was asked to do a presentation around about vegetation and risk management within Western and Wales, and so it's all about new technology that we've been trialling throughout the country over the last several years, and what we have been doing recently. So in Western Route, we have around about 1.4 million trees along the railway, which includes third-party trees. And so how are we managing the risk? So we're using several technologies these days. So it's through aerial surveys, drones, LiDAR and hydrospectral tree vitality survey, digital Lineside inspections, using AVA train videos. We still obviously carry out on-foot tree surveys, and obviously how are we managing pests and diseases throughout. The photographs you have on this slide here, basically we have obviously the Network Rail helicopter that we use, the aircraft as well, fixed wing for using LiDAR and hydrospectral. The top picture is with the AVA Samsung camera attached to one of our trains, and obviously the two photographs below is obviously historical, where we used to burn out Lineside in the 1970s, and obviously a tree incident that happened in Western. So vegetation is one of our biggest safety issues. Basically, it causes damage to obviously our freight and train operators. We have high-speed tree strikes, which can obviously derail trains and obviously kill drivers, including our passengers. And obviously, we have wrong-side track circuit failures, which cause fatal accidents in the past. And SPADs are on the increase occasionally due to autumn and leaf fall. And obviously, not to mention other vegetations around earthworks inspection, stability, damage to third-party property. Obviously, even our own people doing vegetation management itself is a risk. Chainsaw staff, Lineside, signal sighting, damage to structures, block drains, and damage to freight and damage to OHLE. The picture below is obviously one of our Intercity 125s. The train driver was doing 110 miles an hour, came around a corner, and he was decelerating because there's a footpath crossing, and a tree actually went through the cab. Luckily, the driver, with his immediate reaction, managed to hide down behind off his chair, and he sustained crushed shoulders, and luckily he was alive. He didn't sustain any further injuries. So vegetation management across the network, this isn't just across Western and Wales, we have around about 2.5 million trees actually on the network infrastructure, and it would cost around about £2 billion for us to actually manage those. It's true that we can't afford it, nor do we need to cut down every tree. But when one looks at the evidence, it's clear we cannot afford not to do vegetation management. We must do it well and consistently, and just to run the railway. So basically what I'm going through for the next few slides and the rest of this presentation is how we're managing the risk with the new innovations, technology, and ongoing foot inspections. So initially what we do is an on-foot tree specialist survey every 2.5 years, and then every 5 years we actually do a leaf fall calculation. So this is what we call a threats form. It's basically tree hazardous risk evaluation and treatment system. On part 1, hopefully you might be able to see that, is basically description of any of the problems: root damage, root decay, stem, bark, dieback, dead wood, all these sort of issues and nice things you can actually see off a tree when you're walking past. We actually then carry out the evaluation of a sum of the likelihood of the failure, the speed as well of the line, and obviously then the impact from 90 mile an hour if it's anywhere near switches and crossings and viaducts and any under bridges and over bridges and tunnels. It then gets calculated into a score, and therefore we've either got a threats category of either extreme, which is a 7, and insignificant is a low score of 1, and then we've actually got reported timescales to actually manage that tree. Obviously, if it's an extreme, we'd actually carry out, maybe put a line block on, caution the trains and get that tree down immediately. But all the other ones are 24-hour, 72, 7-day, and even 26 weekly response times. Once we've carried out that, this is basically what we're also looking at is obviously for fungi, and obviously we've got some pictures there as well to help us with the examiner to assess some of the issues against these trees. Once we've identified a tree, we usually tag a tree with a tree tag identification number, and then we would then carry out filling out a full report, and this report actually tells you exactly what the hazard was, the risk assessment, and gives you the action day by date, and obviously explains whether the tree needs removing or is it part of a tree, where as you can see the picture on the right hand side, it isn't just one tree being shown, it is actually a group of trees. So going forward, about pests and diseases, we obviously well known that we have ash dieback and also another tree health issue, which is Flora ramorum, which down in the West Country is affects a lot of larch trees which are being infected, and there's quite a prolific amount near the Welsh borders and the Forest of Dean, with over 1,000 hectares affected by this pathogen. It's basically distributed through the rhododendron, and obviously we had quite a significant amount about 4 or 5 years ago down in Bodmin Parkway, where the Forestry Commission had to fell around about 10,000 trees which were adjacent to the railway. It does form part of a public health notice, and people are asked to actually manage these trees under this public health notice. Rhododendron is we had to spray and clear a lot of the rhododendron down in Devon and Cornwall to help prevent the spread of this disease. It has suddenly come back into the UK, and like I say, it's managing mainly around the Welsh borders at the moment. We have ash dieback, that's the biggest hot topic over the last 5 years. Network Rail came we companion with the Tree Council, and we wrote our own toolkit to enable Network Rail to how to manage ash dieback. And so ash dieback is our biggest risk at the moment on our network, going forward into CP6. This is a fungal pathogen which causes death of mature ash trees within a few years of infection. We have an estimated 3.3 million ash trees adjacent to the railway, of which about 500,000 pose a high risk to the operation of the railway. Once again, it's a big cost of how do we actually manage these trees. Like you can see, it's £700 for day work. But the most cost-effective method of addressing the emerging risk is by early identification and being proactive in planning of these infective ash trees. Even so, the estimated ideal scenario will cost Network Rail nearly 400 million. So the reactive cost will be staggering if we don't manage these over the next several years. Basically, it's as bad as the Dutch elm disease in the 1960s and 1970s, and is likely to be majority over the next coming decades. Ash will suddenly disappear from our countryside. So how have we been managing through technology? Well, in 2011, we carried out a LiDAR survey with Airbus. And then what we carried out a survey from 60 meters from the outside running rail. And obviously, if our land was more than 60 meters from the outside running rail, we then captured 20 meters beyond our boundary fence. And what we were capturing was obviously tree height. The picture on the right shows different colors, red, green, and yellow. And basically, we carried this was using, so we had the tree peaks, the tree height, measured against adjacent of the line, whether it was a network rail tree or a third-party tree. And obviously, we captured obviously tree health by looking at using LiDAR and photosynthesis on the leaves, and it actually would enable us to know whether that tree was actually poor or in good health. This was done in 2011, but it was our first time using this sort of technology, and the data was huge in the data bank for us to actually extract it. And it took us initially around about 2 to 3 years to actually fully get our data out of what you wanted to look at. We used it for 2 surveys. One was called Pole Storm and one was Failsafe. Failsafe was one where trees are tall enough, more than 150 mm in diameter, which can fall and fail in front of a train. And we also tried to use some data to actually give us where we had wind strengths of over 50 mile an hour, whether it's northeasterly, southwesterly, where we had a group of spectral trees that are big enough to fall on the railway, to maybe enable us then to maybe put line speeds on within those sections. Unfortunately, due to the data quality that we've had in the past of storm events, it's very hard to actually determine to say that actually within that area would all these trees fall in a 50 mile an hour wind. And so the groundwork hadn't really been fully thought through. So unfortunately, we didn't actually use that data going forward, or that. So what's happening now? So the latest stuff we're using is the hydrospectral. This is, bear with me. What we're doing here is our latest for tree health, and we are using, if anybody knows about hydrospectral, but the picture on the right hand side on the bottom here, you've got true color. When you fly a plane or use even your camera for Google mapping, it basically just uses 3 colors, red, green and blue. So if you take it with your iPhone or any other camera, you just get that sort of imagery with 3 bands. The multispectral is using still the same 3 bands, the red, green and blue. But obviously what we're using there, we're using infrared, and we're using about 10 bands of infrared using a microspectral. And hyperspectral is what we're using now. As you can see, we're using 100 plus infrared imagery, as well as the other 3 categories. And the camera at the top there is only an 18 megapixel camera that we're using on this fixed wing plane. But we're increasing that to 150 megapixel camera later on this year, so the imagery will be even better. So what I'm showing you here is basically the imageries of how we're carrying out the actual hydrospectral for ash dieback at the moment. The picture on the right hand side here shows you a difference in heights that we're flying. So we would fly at 500 meters or even 1,000 meters. The picture on the left is obviously, this is being used in this 80 megapixel camera at the moment. But when we get the new 150 megapixel camera, the photo on the left at 500 meters will be the same picture quality at 1,000 meters, so we don't have to fly so low. Picture on the left, just for people understanding about leaf and how the actual hydrospectral works, is basically because it's a biochemical composition. You basically have an incoming light that gets reflected or absorbed by the leaf surface in the presence of disease or pathogens. The composite structure changes, pigments of the light changes the leaf as a result of the light, and so therefore the light is different. So basically on the one is a nice healthy tree leaf, and on the right hand side is where we have where the light is unable to produce, and actually therefore it's showing us like the brown leaf, and so therefore the light isn't going in. So when the infrared bounces on these leaves, it's actually reflecting back and showing us the density of these leaves. The picture on the left hand side is once again it's showing where we have a class 3 tree, a class 1 tree, and red, obviously red means very poor, green means healthy tree, and obviously the orange means it's on its way. So what I'd like to do, if I can, bear with me, I shall see if I can share you. Sharing that. That's right. There. What we have here is actually an output of the original survey that we carried out a draft on last year. This is on the Swindon main line, and obviously it's got the different stresses of trees, where they've been removed: high stress, low stress, and healthy. And if I zoom in, hopefully what you can see here now is obviously this area here is where the tree has been removed, because this is from the old Airbus 2011 model. So we've actually felled all of these trees originally over the last few years. The green is showing healthy, and the reds is obviously showing where we've got poor trees. So what I can do is I can click on that polycom there, and it tells me the ELR, the distance from the track, the height of the tree, and yes, that tree here will strike our trains if it falls on the track. So basically that'll be a tree that we need to obviously go and manage and remove. I click on the adjacent one to the side of it, which is now saying, so that tree there won't actually hit the track, but obviously it's a low stress tree, and therefore we need to look at it and review it and obviously manage it to make sure it's not going to fall on anybody else, third party land, or maybe do a concertina domino effect of actually hitting another one of our trees. And if I click on a green one, like you say, distance from the track is 5 meters, the height is 4.5, and it's not going to fail on the tree, on the track. So this is what we're developing at the moment. This is the first sort of example we've had. We're hoping to get this out to all of our areas and routes and section managers, so we can actually manage and identify trees and areas that we need to manage. At the moment, this layer doesn't actually have our boundary on it. So what we're going to be doing is adding the GRV layer on here, so we actually know where the network rail boundary is, so we can identify all the trees within our area. And obviously if there's any third party trees that will have an issue like this one here, is obviously it's nowhere near it's to track, but we can maybe identify and let the owners and neighbours know they do have an issue with some of their ash trees. So the next thing that we've been doing at the moment is what we call digital Lineside. I'm talking to myself because I've got two screens working here, and that's it. So digital Lineside inspections is a latest innovation that we've been managing over the last 2 to 3 years. It's trying to obviously keep our basically inspectors obviously having to walk on ballast along the Lineside every year. And obviously with cab riding over the last couple of years, being unable to get into train cabs to actually video or cab ride anything. We've come up with an innovation by using LiDAR, the aerial photography that we've been using, the hydrospectral, also using front forward facing video cameras using AVA, And what we can do is then piece this all together, and it'll give us a baseline to move away from, let's say, more reactive management, and also enable us to have a strategic planning for line-side vegetation. It'll provide a day-to-day tool that DUs can use to plan and prioritise work. It'll establish a principle of targeted prioritisation of volume of vegetation as well. It'll enable us to be one visit planning principle to be established, and user intelligence to maximise efficiency of action zones. And like we've said before, it will hopefully reduce the on-foot lines of vegetation or an arbor inspection by at least 80%. It'll provide suitable control of significant emergency threat of ash dieback and other similar threats thereafter. So vegetation encroachment, once again, this is what we can use by our aerial photography as well. The picture on the left-hand side is what we've taken from our standard. So what we expect is obviously the immediate action zone is the area which is critical for signal sighting, OLE, P-way, train strikes, and that is a key area that we need to obviously try and keep maintained and clear. We then have an action zone around the outside and obviously an alert zone. And that's what these three colours on the top photograph show: the red, orange and yellow. And so what will happen is the inspector from the digital Lineside inspection will be able to see that pictorial and obviously identify actually the red areas, the key areas that are non-compliant. And we also need to manage those as safety and risk. So then now I'll just try and show you a video that we carried out this morning. So bear with me. So what we have here is this is our AVAR, front forward facing camera, that we use on our trains. We also give it to our inspectors now to be able to put it into the cab. So rather than actually sitting in the cab with a train driver these days, we can video virtually every part of our network. This was done this morning to Falmouth, from Truro to Falmouth, and hopefully if I run this, you should be able to see basically the quality of the picture. And it's like I say, it's not your iPhone, it's just a Samsung mobile phone. So also you can get linked up to using thermal imagery as well, because we've used that on Third Rail down in Kent and Sussex. And what we can do, we can take pictures, we can measure from the outside running rail, and you know, it's the data quality and uploading is instant. Once the guy finishes off the cab after 20 minutes here, it literally only will take about half an hour to get uploaded into the system, and anybody can review this, and then you can fast forward it. And I don't know, Gilles will tell me that he's got a load of weeds in his ballast in his forefoot that he'll want clearing and de-vegging. But it gives us, we can pause it, take photographs, look at signal sighting as well. But it's all part of this digital line-side inspection as well, so you actually can get clarity, and it will help with all the three aspects that we are using. Bear with me. So what we've also been using lately is we've been trialing drone technology, because obviously that's been widely used across the network for all types of things, whether it's been earthwork failures or emergency responses. And so we've been trialing drone technology. Railscape was a company that we used over in Anglia to trialing out how to look at vegetation for using a drone, because obviously it's much cheaper than using fixed wing aircraft and helicopters. Basically what we did here, we actually took over 273 images, and then we actually stitched them together to obviously look at 200 meters stretch of track. So what we are unable to do is we're actually able to do a 3D model of looking at the, maybe that's what we did, on slide too far, is actually we can actually put our boundary or our immediate action zone on top of the grid, and actually we can actually see all the vegetation that is within our immediate action zone that needs to be managed as well at a quick glance. And then what we can do, I'll show a little video in a minute, it's a 3D model that we can actually look at our peaks and troughs of the vegetation within that section. And then we can actually calculate the volume of vegetation. So when we're doing our annual business plans, that we can actually calculate how much volume of vegetation we would need to clear along a certain stretch of the track. So bear with me, I shall see if I can run a live feed. I'll just show you the model. Hopefully this will work. So as you can see, we can actually rotate this using the 3D model. It's just buffering at the moment. You're going to work. I want to play it. It's been working this morning. So it's just quite large data. No, it doesn't want to play. There we go. I'll show you another one. But this is basically how we can measure and do a cut at the 6.5 meter clearance. Basically, this is a demo at the moment, but it's in development, where we can actually take out that volume and actually then just see what actually the line side looks like, but also then calculate, like I say, how much vegetation actually requires to be removed. Sorry, in 2 seconds. So yeah, so I know I've just showed you the 3D model, but basically what we call a 45-degree angle. You know, the running rail at the bottom, and basically we have the action zone action, and what we want to try and do is obviously manage our vegetation to a 45-degree angle. Doesn't mean clearing everything, but this sort of demonstration, this 3D model, will assist us to actually manage going forward and actually being much more productive of clearing our vegetation. So I'm just about to come to the end of my presentation. So if anyone's got any questions, which I'm sure Jill hopefully may have, just to let you know, the tree in the middle was obviously one of our trees that fell on a third-party land. The tree on the right-hand side, unfortunately, the train driver didn't survive, and that was obviously in Germany. And I have my loss witherall Dalek on the left-hand side after the scarecrow competition that somebody decided to put on one of our bridges. You there, Gilles?
Okay, yeah, thank you very much, Gideon. Are there any questions? So if you've got any questions, please put your hand up, and then I will call you to ask a question. Hi, Chris, do you want to comment?
Hi, Gilles. It's Chris Preston here, formerly Chief Topographic Surveyor for Network Rail. I was very much involved with doing the aerial survey contracts when they were first let, and it's great to see the advances that have been made in using all the data now. And I'm really pleased to see such terrific work being done that's helping the organisation. One hopefully relatively simple question for you, Gideon. The time of the year obviously has an impact on the vegetation that is seen. Do you try to do these surveys with full vegetation, or do you do them in the winter? What's the norm that you would expect to do?
Right, that's a good question, Chris, because we trialled last year. We did obviously had to for EdXL to actually come forward to say that using hydrospectral, especially with tree health, you're right, we need to have the foliage on the leaves. We need it in bloom, really. And ash is a tree as well that it still hasn't, you'll notice even if you look around the roads at the moment, it's one of the last ones to actually grow its leaf. And so it doesn't really come out till about May. So we did trial certainly in the spring, almost like say now April, flying. But what was happening, we were picking up a lot of hawthorn and blossom, was actually causing some of the poor data that we were getting back, because obviously with the infrared coming down, it's actually picking it up as a class 2 tree and wasn't actually identifying it. So for flying for ash, we're having to fly between May and September. But obviously our on-foot inspections, you can carry those out on foot, nearly 12 months of the year now, because you can see a poor tree health, if it's got fungi and all that sort of thing on foot. But literally all the aerial photography, to be honest with you, is really sort of May to September now. Chris, that's what we're doing.
Thanks very much.
Right. So if there are any other questions, please raise your hand. I've got a question, Gideon, myself, regarding the environmental impact, because it's a huge number of trees that we've got to manage and remove, as you explained. Of course, I suspect there is a lot of ecology, animal or plants, that thrive under the current environment, and removing the tree will impact them. So what are the consequences and mitigations around your work you're doing of removing and managing trees?
Yeah, I mean, as a company, we have what we call a sustainable Lineside partnership. We're trying to look at ways of mitigation. A lot of it we have done in the past of purchasing or planting trees and moving, especially people like dormice, off our infrastructure if we can, by planting hazel trees adjacent to the railway to try and actually get them to migrate away from our infrastructure so we can actually maintain it. So we are doing a lot of work by working with other organisations around, whether it's local authorities or other work groups, to actually look at tree planting, necessarily not always trees, but also looking at other small flowers and fauna to enable, bees and flies and insects to actually grow and actually build up part of this corridor, a green corridor from like north of England to the south of England, where all butterflies, wasps, bees, insects can actually fly from one end to the other and increase that sort of biodiversity. But yes, it is one of those big issues that we do get, obviously, a bit of bad press about chopping down trees, but obviously for safety we have to do it. But that's why we're looking at mitigation of not chopping down every tree. A tree doesn't necessarily need to be felled. We can crown it, reduce the height of it, lower it, but doesn't mean we actually scorch earth. That's not what our policy is these days. So we are trying to manage and replant through ecology and biodiversity, offsetting it.
Yeah, thanks, Ian. Very interesting. Okay, I've got another question waiting for others to chip in as well. The imagery that you show us is very good, and I was wondering if that was available to track engineers, for example, to use, because they seem to be fairly up to date.
Yeah, I mean the AVA front forward facing video camera is basically live data. We do it during the day, night. It's actually put on the MNT trains. I believe some of the track workers have used it, have access to it, because like I say, it covers the whole of the area. They are putting more technology into these cameras to, like I say, about hotspots and places like that. But yes, and with the LiDAR imagery as well, the pixels and going down, looking from aerial view down onto the track, because when the 2011 Airbus was used, one reason why poor old Vegetation was sort of like lacking in behind was basically all the other asset owners, whether it's structures, whether it's OLE, everything, drainage, earthworks, they all wanted the data, and so therefore they were getting the information much sooner, because it's easy to extract that sort of data for them than obviously what we were after. But it can be used by multiple assets, and it's not just for about vegetation. Once we do these aerial photographies, all the asset owners are using it, like the drone we've used for structures and earthworks. And so yes, everybody is trying to get a piece of the action.
Thank you very much, Gideon. Right, I can't see any other hands up, so I think I'm going to draw then this session to a close. So on behalf of hold on, we've got somebody, Vlad. Hello, Vlad, you got your hand up? You may want to unmute yourself.
You'll think you'll find he's got questions in the chat, Giles, so I don't think you can speak.
Ah, okay. I didn't realize that. Okay, I was not monitoring the chat. Okay, so yeah, I can see that. So excellent software on ideas. 2 questions, please. Did you say 6-meter corridor from the rail? Should it not be from the edge of the ballast stop?
I see that. Yeah, I mean, we for us to be able to use a fixed point, we actually use the outside running rail, because obviously the rail's not straight half the time. So if we're using ballast, it can obviously deviate. So we actually try and use, we've always, for vegetation terms, we've always used the outside running rail as one of our fixed point measurements. So that's what we use rather than doing the ballast top. Also consider predominant wind speeds. Yes. Windy mountains would provide a safer track on average. When we looked at, we haven't actually done any more calculations on wind speeds, because it's trying to get the amount of storms we've had, the amount of tree failures we've had. The majority of them have been third-party trees, to be honest with you. there isn't that large volume and data for actually to compare apples with apples. So when we're on the ground evaluating that tree, and then 9 times out of 10 that tree has fallen, we don't capture the data of how it fell, whether it was just uprooted because it was just strong wind, was the tree healthy, was it decayed, and so we haven't. So to try and actually, we have to have more incidences to actually use our data from the LiDAR to actually say, the stuff we're being flown above is actually what's happening on the ground. And it's at the moment have been looking at it, but we still just don't quite have that data at the moment.
Okay, thank you, Gideon. Right, last call then for question. Okay, thanks for your comment, Vlad. Right, okay, so Gideon, I need to thank you very much for coming and do the presentation today. I think it was very interesting a presentation, see how technology is used and developed to actually help with scoping and managing the problem with vegetation. I must say that the scale of the issue was unknown to me until you joined the team and opened our eyes, to this problem. So as I mentioned earlier, very glad also to have had you, because I think PWI will be able to offer a path for professional registration to the engineers that work within your field, so geotechnics, Lineside, and drainage, and all the things around that. So it was good to come and show us, all the good work on the advances that have been made within your field of expertise. So on behalf of everybody on the call, Gideon, again, thank you very much for your presentations, and thank you to everybody for attending today. And I wish you all a good day, and I'll see you in 4 weeks' time.
Thank you very much.